I think should be quite okay on the same axis. So sketch these two. This one, I think from GC, you should know how to key in, right? So y equals x over a and b x minus a. So just use your calculator here to do. Just make sure to know that you have a vertical asymptote here. Very important. So it's like x equals to a. This one equals to 0. There's a vertical asymptote. Okay, so that's very important there. So key in calculator, this will be just pick any a value will do. So you have got 1 over x minus a. So I'll let my a be 2. All right. Then after that, I've got let my b be, let's say, I'm not sure. Let it be 3. So 3 modulus. So modulus, you go to math, and then just go absolute there. Then press x minus a. So a is 2 here. I use a as 2. It doesn't really matter what kind. Okay, so it's zoom standard. So this is the graph that we're looking at. Okay, so you can just zoom in. Let me just zoom. I'm just gonna minus 5 here. 5. Yeah, make it looks nicer here. Okay, I think that's about it. This is the graph. Then you can see the vertical asymptote. It cuts down here. So just plot this graph out. Label everything nicely. Yeah. So once done, just plot everything out. Okay. We're quite okay. So label all the asymptotes out. Just label them out. This is y equals to 0. Please remember y equals to 0. Do we need we don't need the equation of asymptotes. My goodness. So this one, if you don't label it, you still get the full marks. Because they just want you to plot it in the same graph. They never say you need to label everything. But of course, as Singaporean students, we usually just write everything out because we are fearful, right? Yeah. Right. So label everything down. Then label the rest down. So in this case, y, x. So when x is 0, this y will be b 0 minus a. So this is just ab. This will just be ab. So label this as 0 comma ab. X equals 0, right? Y equals 0. This will be a comma 0. The asymptote is y equals 0. X. Right? It's okay. So this one is 0. It's okay. In exam, you do not know that this is on the asymptote. What you do is actually you can actually draw a vertical line. So if you follow me very carefully, So you just press trace and press 2, and then you just go to this point here, right? Then what you do is you see this draw here, second draw, you put vertical line, the vertical line 4. Okay, they aim soon here. They'll give you the vertical line there. Okay, so what you do is, I will clear this first. Yeah. Okay, here like that. Press trace. Because this one it's gonna cut through here, right? So anyway, you want this point here. You want to see whether this is a vertical asymptote. You just press trace equals to 2. Then you just press draw. Second draw. This draw here. Okay. Second draw, then you go to vertical, press 4, then you can actually place your vertical asymptote here. Okay, and just press 2 like that. Okay, yeah, just for visualization. Yeah, that's about it. If you missed it out because this one got unknowns So for solving the inequality, I think a lot of you already solved it already. So just take note, you need to break this apart. This modulus graph have got 2 equations there. Okay, so this one will be y equals to b x minus a, or it will break into y equals to minus b x minus a. It doesn't take long for you to know that the graph of this, to find this intersection here, There's only one intersect, right? There's only one intersect, right? So this intersection here, you just take the y equals to bx minus a because it's positive sloping. This one is negative sloping. But of course, you don't just base on this because sometimes this one will be negative x. So you just expand out. If you're not too sure, just expand. This gradient here is positive. Wait, I cannot assume b is positive. Is b positive? Yeah, b are positive. So b is a positive constant. That's why you get this part here. So if you want to find this intersection point, so to find the intersection point, what you need is take this equation here and solve with this equation. Now you will get two solutions, right? You get two solutions because when you take this line equation and intersect with the rational function there, you'll cut here as well. Okay, so just take note now. You need to reject one. So you need to eyeball this. Whatever intersection you find, this must be bigger than a. Okay, this x here will be bigger than a. Take note because a is here. Okay, so just take note of that. So essentially what you get is bx minus a. Now, like I say many times, A-level questions are typically like that. Very elegant because you're working, you don't need a lot. It's heavily relying on concept. So if your concept screwed, you pretty much screwed here. You see this one is a very easy equation to solve. Right? This will be x minus a square over b. Plus minus, this will be plus minus 1 over square root b. And then x is just a plus 1 over root b. Or a minus 1 over root b. So just reject this one because it has to be bigger than a, like we already established, as x has to be bigger than a. So this intersection point here actually a plus 1 over root b. Okay, not too bad lah. You need to find that. Then after that, you just want the rational function to be smaller. Rational function to be smaller is anything below the modulus graph is here. Let me just draw it out. It's just here, below here, and then the rational function below here. Okay, so don't forget the one on the left, left tail also below. So essentially your solution that you're looking at from graph, part 2, from graph, is less than 1 over x minus 2 is less than b x minus a when x is smaller than a, or x is there's no equal sign, x is bigger than a. Okay, there you go. There's your answer there.